Good afternoon, everyone. Today, we would like to report our research project for the course Advanced Manufacturing. Our project title is High Efficiency and Environmentally Friendly Elastocaloric Device Model. The first part is the background. According to the USA Department of Energy, 20% of the world's electricity is used for cooling, and many regions exhibit an upward trend in cooling degrades, indicating a gradual increase in demand for cooling. However, traditional vapor compression technology has a great impact on the global climate. According to the CCPI, greenhouse gas emission could push temperature over 3 degrees by the 2040s. At present, countries around the world are calling for energy conservation and emission reduction to achieve carbon neutrality. At present, the most potential energy saving and emission reduction method is the use of green refrigeration technology, such as elastocaloric cooling, because it has the highest energy efficiency ratio. The principle of elastocaloric cooling based on nickel-titanium chip memory alloy. When the material is subject to stress, the phase transition will be introduced. When the austenitic phase is converted to mastenditic phase, the temperature of nickel-titanium chip memory alloy will rise, and the temperature will decrease during the reverse phase transition.
Okay, next up is our coursework. We want to build a mini version of elastocaloric refrigeration machine by using some of the machining process we have learned in this class. And this will allow us to become more familiar with what we have learned in this class. And of course, this prototype is just a display model, and does not have a real refrigeration function, since it would take a lot of money and many hours to make a real elastocaloric cooler. Yeah, and that is not quite possible in this class. First, we need to make the body of the prototype. We used the school's 3D printing equipment to build the construction of the main body. And then the whole external display box, we made it this using wire-cut acrylic sheets, which gives the external structure some strength and make it easier for people to see the construction of the prototype inside. And the last problem to be solved was how to place the prototype in the center of the display box, right? Because that will be easier for you to see the prototype inside the box. So we used the CNC to make two work type brackets to keep the prototype suspended. And by this point, we have completed the entire main body of the design. But we will also create a few more internal structures to better demonstrate the functionality of the prototype. Yeah, we will experiment with wire cutting and 3D printing to make different tubes and sleeves. And of course, we want to try more ways to build this prototype to make it more functional. And for easier viewing, we will place the fabricated parts under the prototype. Yeah, that's our proposal, and that's what we want to do in this class. We want to use as more as possible tools and processing uh, to 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 finish our coursework. Yes. So here is what we fabricate for this class from what we learned in this class. And the core part in our model is a 3D printed prototype, as you can see on the top right corner of the picture. So this part is by 3D printing from the lab using PLA material, and the structure was supported by extensive fabricated support using aluminum, and the entire prototype model is holding the laser cut case using clear acrylic. And beside the outer prototype, we also made some internal parts, as we mentioned in the previous slides. So, like as you can see on the bottom part of the slides, we made several cases, which we call the buckling prevention case for the nickel titanium tube during compression in the prototype. So we made we made one model using aluminum from CNC machining from our factory, and also we use 3D printer and PLA material to print some cases because we can use in our model. And also we use the EDM wire cut to cut a nickel titanium tubular structure, which is also what we used in our real prototype in our lab. In this slide, as you can see, this is a comparison picture of our built model and the real prototype from our lab. And this way you can see how do we compare and how to show this structure to our audience. Thank you for listening. This is our work in this class.